DSG and also UCREL. And most of all, thanks for all of you for attending today. And I can see more and more people are joining us. So as Gloriana said, I'm going to start with a short presentation just to give you a flavor of what visualization is. And after that, I'll move into the tutorial. I'll give you a roadmap of the stuff that we're going to talk about. So the tutorial today is mainly me running stuff in front of you using Python on Jupyter. And then I'm gonna make the GitHub repository publicly available for everyone to use. So I'll try to do that within the break. And then later on, you can run that on your own, on your machines, and then update that to suit your project or the work that you're doing. Okay, so visualization. So this is an interesting topic and works across a lot of fields. It's a multidisciplinary thing. So yes, I am visualizing a corpus, but a corpus could be any textual data from any background. So people in history, linguistics, humanities, computer science, they all have data in a form of text and they want to analyze it. And most especially, they want to visualize it. So here we begin. All right, so what is visualization? So we're looking at two different photos of what I call visualization. So the time span between them is 5,000 years. So on the left, we see the first hand-drawn kind of like human craft on inside caves somewhere in Eritrea. And this is someone visualizing a scene. Okay, so they are trying to show you things that happen somewhere in some manner and then try to describe what they've seen. Maybe this is not visualization of data, but it's a visualization of a scene. And on the right, we have, again, another visualization. Maybe they're not the same animal, so I think it's a camel and a giraffe, but it's still kind of visualization. We're trying to say something to a kid to say, you can measure your height. Here's a chart that looks like a giraffe, and it is kind of a visualization. You don't need an actual giraffe inside your house for kids to measure themselves against. So basically, you're trying to communicate a message. So I have a message in my data, in my results that I want to communicate to people, but I don't know how to do it. So the best way to do that is visualize it, right? I'll put it in some kind of a graph or a diagram or a chart, and I say, this is what I'm talking about. This is the results I got. And that's where it's exciting, for example. Okay, so what do we need to visualize in our course? So we're going to visualize text, a lot of text, data, a corpus. So a corpus is a collection of text. It could be about anything you want. You've got plain text. You've got data that came out from analyzing or processing a text, and you're stuck. You want to show what's happening. So I'm going to help you do that. I'm going to help you visualize your corpus in some way. And here we go. And I'll be looking at the comments every now and then just to make sure if there are any important questions that I can pick up while presenting. But I can see a lot of people saying they can see the presentation, so hopefully we're good to go. Okay, so why do we need to visualize? All right, so visualization is an interesting thing. So basically, if you have data in text, you as a human can read it, right? Because that's how you understand it. You read the text and you know what's talking about. Then you want to give it to the machine. So you want to make it machine readable and also do some kind of vectorization in order that the machine to know what you're talking about in its own way, in its own language. And the machine speaks numbers, right? Binaries, 0 and 1. So all that text you see is going to be converted somehow for the machine to understand in its own way. So the machine does all that analysis, gets the results and shows it back to you, but it's a lot. So there's a lot of data. You can't read it, the machine can read it, and then you want something in between. So you do visualization, right? So you visualize the results that the machine came up with. So the machine can read that visualization because it created it through you. And then you, the human, can also understand that chart or that visualization because you order it to happen. So both of you can actually read the same thing. Both of you somehow understand it in the same way. And you, the human, then can make findings or come up with conclusions to say, look, there's a spike here. It tells us something. right, so isn't the data as it is enough? Or do I really need to visualize it? Like, what would happen if I just say, here's a bunch of text, you people figure out what you want? So the issue here is actually mainly time. So if I give you this text and without saying anything, I'll just come back to you and say, oh, tell me what this text is talking about. So it might be manageable. I've got a one piece of text in one document, but what if I have 10, 20 documents, millions, billions of words? So that when it's become very challenging and time infeasible because I can't figure out what's talking about in such a short term. And also, most importantly, I can't find the patterns that I would think are exciting and that I want to focus on in my research. But on the other hand, if I give you a word cloud like this, which exactly created based on a big portion of the text we've seen before in the previous slide, and then I say, what is this talking about? So this is just a word cloud with font size that could mean anything, font color that could mean anything, but then I can see the words. I can see words such as source, browse, bug, change, process, chip, machine. So suddenly I'm talking about something related to computing. There's software, there are tools and infrastructure. Then I see the word talk and I said, talk and computers, what could that be? And then in the end, you start to think this could be a conference on computer science. And that's what I'm looking at. I'm looking at data talking about technological stuff happening within computing. So far, I didn't know anything about this chart or what is it presenting? So what does a big font mean? Is it like most frequent? Is it like most relevant? We don't know yet, but I know it's telling me something. And that's when you start to explain it to the people reading it. So that's just a simple version of visualization, and it's called word cloud. And we're going to have an example on that and look how it works later. So basically, yes, people don't like to see data in plain text. They want charts, right? You go to a conference, you present your results in text. They won't get it quickly, but if you put charts, a lot of people will have different conclusions because that's what they like to see. And I do agree with this meme. So what can we do with text? And most of those, if not all, we're going to see them later in the tutorial. So for any text, you can do a tokenization, which basically you split a text into tokens, could be words on white space delimited text or any other delimiters in different languages. You can do annotations. A lot of you might be familiar with annotations. You annotate a text with labels such as the part-to-speech tag. Is it a verb? Is it a noun? Etc. Could be like named entities. Is it a person name? Is it an organization? Is it a location? Then you can go an extra level and say, I want to do topic modeling. I've got a lot of text and I want to know what topics they're talking about. Okay, could be for any task you're doing online or any analysis you're doing with your data. Then more exciting, you do machine learning. Okay, so machine learning takes your text with labels, could be supervised machine learning. You train it to do something and it learns itself and comes back with an accuracy and it says, I think I'm ready, 80% to do a classification task. But all of those, okay, are like kind of data. They are represented in numbers on machines, in vectors, large number of vectors, as we can see later. So when you do most of these, you're doing it on your own for your data. You can provide that data, but when you want to talk about it to others, you need to visualize it. And that's when visualization comes. And in the language of meme, if anyone is familiar with a muscly dog, so you know that visualization is the one that you stand out with to say, here I am presenting my results for all the things I've done before using machine learning. Cool. So this is what I'm trying to do today. I've got data and I want to visualize it. So I try to plot it. And here I am in front of you doing a visualization and using charts, diagrams, anything that could be visually attractive for you to look at and come up with conclusions or understanding for the results I've got. All right, so let's have a look at a sample. So assume I've got these 4 sentences. They are what we call plain text. So I added the tags just so you know that a start and end of each sentence. So just plain English sentences that talks about visualizing a corpus, what's the text visualization, etc., etc., and that today is the 18th, and I'm showing you how to visualize simple text. So part of the things that we mentioned before is tokenization and annotation. So tokenization is knowing when a token starts and ends. So I know the word visualize is a token on its own. Same thing with my corpus, etc. And then I add tags through annotation. So the blue ones in the first three boxes are what we call part-of-speech tags. So those are tags from the grammar. They tell you the part of speech for each word or token in there, whether it's a verb, a determiner, a noun, etc., etc. And that's a way for a machine to start to understand what your text is talking about, okay? And then on the other hand, in the red box, we've got what we call named entity recognition, NER. So NERs provide such labels, and those labels are related to certain categories, and it's up to the tool that's doing the annotation. It could be 4, 5, or 7, or even more. So for example, the machine, because it was trained on data before, it knows that a phrase such as today is March 18th is a date, and that my name is a person, and then Lancaster University is an organization. So here we're talking about some kind of annotation. So I've got my data tokenized, annotated, but it's still hardly presented. So I can't present that unless someone knows what I'm talking about. But I want to like visually present it. I want to do visualization. So that's when we come to tools in Python and libraries that allows us to visualize and communicate what I see in my annotated text into figures, diagrams, and charts that others can look at and understand using colors or whatever. So we can see that we've got dependency trees in most of the ones that where I use part-of-speech tags. It tells you about like a sentence, like proper nouns, compound sentences, etc. Sorry, variables. And then in the middle box, we can see the coloring for the named entities, right? So it says if it's green color, it's a date. If it's purple color, it's a person. And then again, blue is an organization. And that could occur to all of your text. So a way to help you visually understand or look up information that you really need to look at. So the dependencies used here is what we call the universal dependencies, and the link is down there. So to help you understand more about what kind of dependencies that we see in here. Okay, so what can visualization tell us? So I'm going to take you through a few examples of visualization tools that we have online, not mine. Other people made a huge effort, trained data, and they created a visualization process to show you information and help you find information and spikes in time that you think are important or interesting to look at. So basically, we're trying to find things that we don't directly see in the text. So one of them is the visualization of Reddit. So I'm sure a lot of you are familiar with what Reddit is. It's a social news aggregation, web content rating, and discussion website. There's a lot of discussion about the age and gender of people using this, that being the young people, mostly male, but I think it's changing since 2015. But we can just, for our example, think of it of this is how the internet talks, although it's just Reddit, okay? So in this visualization tool from 538, which is a website, you can see down, so it's a project. So they've collected data from Reddit, I think between 2000, let's say 5 and 2017. And it's just mainly text. And it allows you to search for certain phrases or words that you think are interesting or you want to look for. And then it's up to you how to interpret that. So when I went in and I just typed Trump, Obama, and vote. I wanted to see what did people talk and around what time. So in 2008, that could be the last term for Obama. There was a lot of talking about voting, and then Obama himself, and that's when, let's say, got elected. I can't make that conclusion, it just happened. And then it went quiet through the years, and we know that the election started again. in 2016, and a new president started to like emerge, and now there's a lot of talk about Trump, and the spikes tell us maybe was he more like favored than Obama, or is it just Obama's finished his term and can't go for further? It's just this is what the text is telling me. So this is kind of what information you can pick up from visualizing a text, rather than just you reading between lines and try to find out or come up with a conclusion. Another example is I just decided to see, can the visualization tool here figure out when a certain trend just came out and people started to talk about it. I mean, I know the percentages here are not high, but can still tell us that the spikes are kind of at the right time, at the right place when they were just trending. Okay, so we got stuff like the royal wedding, talking about Mandela, Gangnam Style, the ice bucket, and you can see each one of those is spiking exactly at the period when that event happened, which means people talk about things around them. And it does help us to understand how people talk. So that's what the visualization here is telling me. So, and again, the same way you go with your data, you analyze it based on a certain hypothesis and you say it agreed or didn't agree with the hypothesis. The same thing you do with the visualization. You're just visualizing the results you've got. Okay, and what other things can we visualize? So, so a study by Matt Daniel actually visualized lyrics of hip hop, okay, for the most famous hip hop singers in the world, I think, and just showed you a diagram. This is what we look at is a chart saying which of those used unique words in their lyrics. And then we can see a lot of people have repetitions, and then it's just dense in the middle. And then someone at the end of that shows that they use a lot of unique words in their lyrics. They don't repeat a lot. And one of those was like A$AP Rock. And in that, it was actually like discovered that he's using a lot of words in his hip hop music or like songs that could actually be compared to like Shakespeare's or Herman Melville's Moby Dick or whatever, of the uniqueness of words and phrases. So whether this is true or not, it is just an analysis based on text, and that's a conclusion that I came up with. We would never knew about this unless someone actually collected all these lyrics, done the analysis, and then plotted the results in front of us and said, look what I found. So that's exactly what you're trying to do when you visualize text. Okay, so this is interesting, but by the time I did it, Flash was still working. So now Flash is dead. And unfortunately, this doesn't work. The link still exists. So it's just, I think, time until maybe Stanford update this. But what is this telling us? So someone at Stanford collected all the PhD dissertations from the 1993 up until 2008 and tried to see, based on a certain topic, what other topics or fields are related to it. So because I'm a computer scientist, I was actually interested in computer science and see what topics I'm closer or becoming closer to computer science just based on PhD dissertations. And then from the chart, you can see the colors going down saying I'm more related or coming closer. And one of those you can see linguistics, philosophy, and like engineering, they are coming closer towards computer science. And that's when we know that there's a lot of multidisciplinary work happening in this field, like genetics and computer science, for example. And so this is what kind of information you would like to figure out from analyzing text and then find the perfect way to visualize it back to people to like communicate the results you've got. So that's why visualization is really important, because it's your way to actually deliver that message to the audience. Okay, more. So this might not tell us much, but Stephanie decided that she can draw text, and she does that well, and she does it manually, right? She makes a lot of trees and like diagrams by visualizing text in her own way. And then someone liked the idea and actually converted that into a code. So what the code does is it goes through a certain text. So I've taken my paper here just to start. And then for each sentence, based on its length, it turns right. So what we'll have is a lot of like right turning based on the sentence length, and then you end up visualizing your paper. This might mean nothing, but you can maybe just print it and hang it on the wall or whatever. It's just like a way to tell you that you can actually draw text if you want to, and it's up to you what kind of conclusion you'll figure out from this one. Is it complicated text? Is it easy text? Etc. etc. Maybe if I have a lot of comparisons, I can maybe come up with a conclusion. So the code for this is available on GitHub, and you can also try it on my website. There's like other papers and documents that you can visualize and see how they look like. So more, I mean, if you search the internet, there's loads and loads of ways to visualize your text and data in a nice and neat way. WordCeft allows you to like do word clouds, and it gives you a trees of synonyms for a certain word, like as we can see here, country could be like a rural area or a land or an area, etc. There's also like Word Wanderer that finds relationship between words. The one we see on the left down there, it's more about like a concordance, and I put an example just to see what compares to Alice in Wonderland. So that's how they do the comparison. So it's just to see that the word voice in Alice in Wonderland actually refer to someone's voice, while in conferences, voice could relate to like voicemail or voice over IP, etc., etc. So more links and places to go like to and find more about visualization. The website by Jem has a lot of interesting stuff and a lot of interesting visualizations that you can do with your data. D3JS provides a lot of visualization snippets that you can use and start to visualize your CSVs, for example. So yes, have a look at all of those and see what tools are there available for you to directly use. But later on in this day, we're going to talk about tutorials. So I'm going to use Python in order to visualize. So what are we going to visualize today? So I've got a data from the CCC conference. So this data is basically from the 1980s, I think, up until 2019. And it's every token abstract been submitted to this conference. It's multilingual, so it's English and German. So you'll find a lot of German words in there. And this is the link to my tutorial, which I'm going to release later. So if you click on it now, it's not going to work. It's still private. And if you're interested in the conference data, it's on the link down there and also in the GitHub that I provided. So yes, so we're going to look at a few tutorials. So what are those? So I'm going to start with a simple introduction to Spacey. So for those who know Spacey, it's a way to do NLP and tokenize, tag, and annotate your text. We're going to do topic modeling and see how we visualize that. And again, word clouds with visualization, machine learning with visualization using confusion matrices. Just going to show you word usage because we have data from conferences across the years, so we can see what happened to a word. Is it overused or underused? And then finally, we're going to look at word embeddings and how we can visualize that using Python. Okay, so that's the end of the presentation. Which, as I said, it's just a short introduction to tell you what visualization is. And next, I'm going to move on to the tutorial. So I'm using Jupyter. And if the font is small, I'll zoom in. But if the font is small, you can just type in the chat to say, can you zoom in or out? If you're using like a tablet or phone, you can actually zoom in Microsoft Teams if you want to look at something in more details. Okay, so I'm going to share my screen now and go to the, so I'm going to go to the page, which is, I think here. Right, just make sure your cameras are off because this is recorded, so unless you want to be in the recording. Okay, so I think you can see my screen. So this is the GitHub, which I'm going to make available at some point. I think I can do that in the break. The The other thing is, what you do is you clone this to your machine, and then you run it on Jupyter. So you need to search online to find out how you can clone from GitHub, and then how to run it on Jupyter. Because I'm using Windows, it might be slightly different. So when you open it on Jupyter, you'll find the 6 tutorials that I mentioned. So we start with Spacey and end with word embeddings. I tried to put the requirements, but this is basically all the requirements I use on my machine. So you can just check the import statement and then check what requirement and what version used, but this could be very specific to my machine, so I'm not 100% sure it's going to work. Some directories for us to present the output, and then we can look at them one by one. In the CSVs, you'll find all the CSVs from the conference for the past years. Okay, so here we go, the first tutorial. So I'm going to talk about Spacey. Fingers crossed, everything is going to run fine. All right, so I tried to do and add as much documentation as I can, comments and notes to tell you about things that you need to install or you need to have for this to run fine for you. I also put the link to the GitHub here, so when I release it, you can just find the GitHub link here. I can also email you all through Eventbrite. Oh, by the way, someone asked me about certificates. So what I'm going to do is, I've got all your details about in Eventbrite. So what I'm going to do is generate the certificates and email them back to you. But if you think the details are wrong, you can email me back later and say, can this be updated? All right. So you need to install Spacey. So best way to go to their website and check what is needed to download it or install it on your operating system. So as I said, the data we have is in English and German. So that's the language models we're going to use from Spacey today. All right, so I'm going to start. So I've divided this into cells. I run the output for each one of them. We go one by one and make sure it's running and then move to the next. So you're not overwhelmed with a lot of things happening at the same time. Don't worry at the moment if you don't understand Python or you don't know what's happening or what's the exact usage of a certain method. I'll try to explain as much as I can, but I'll leave it to you later to explore more and search online. So this is just to help you kickstart with visualization with the simplest methods I could find for you to do. Okay, so in the first cell here, we just do an initialization. We're calling Spacey's tokenizer. The language I'm using here is the English language. So I'm loading the model, and I have an empty tokenizer that is ready to tokenize or split into words any English text. So what's the sentence? So I've got the following sentence. It says, today is March the 18th, etc., etc. And I'm going to show you how to visualize a text. So if you notice, I've added extra spaces just to make the tokenizer fail, because with more than 2 spaces, the tokenizer starts to consider that as a token. It, of course, depends on the tokenizer itself. I'll show you how to do cleaning to the text and other things. So here we start. As I said, we had an empty tokenizer. So we run it on our sentence above there. And then all the results are going to be in this list called tokens. Okay. Actually, this might not be relevant anymore. So what I'm going to do is I'm just going to print the length of tokens. So how many words are there in this list, and then print each and every token in that list. So I need to go back and run those. So you click here on Jupyter to run. Sometimes there's no output, so you don't expect anything. But here we're expecting an output. So when I run it, it will do some processing. You can see up here on the right, when the circle is full, it means it's still processing. So what this is telling me now, that based on white space, I've got 21 words or 21 tokens, and those are the tokens in that list. And you can see some spaces are wrongly being considered as tokens, and that's when you need to do some cleaning. We've got some punctuations here and there that also need to be removed. So the best way to clean text, sometimes it depends on the package, but in Python, regular expressions are known to do well with text. So in the first one, what I do is I remove extra spaces. In the second one, I remove everything that is not a word or a space, just to get rid of all these unusual characters. And then I call the tokenizer again, and then do the same as up there, just print it. So this says now, after cleaning and removing extra spaces and punctuations, I ended up with 18 words and there's no spaces, okay? So this is just to show you what cleaning does and why tokenization is important, okay? So what about stop words? I'm sure you've heard of stop words during your research and you wondered how to get rid of them. So stop words are, in any language, the most common words that appear in a text, like articles, prepositions, like the, in, out, they, etc. So these are things that you don't want to see sometimes. Sometimes you want to keep them in if you're creating a language model. But in here, we just want to get rid of them to see how it looks like. So I'm going to import the English stop words list from Spacey and just print it to show you. So when I do that, it says, here is the list of stop words that Spacey uses for the English language, like together and cannot and quiet and all these words that are very, very frequent and has to be removed. Okay, so what I'm going to do now, I'm going to create a new variable with the stop words removed and then print that. So do that, no stop words left because of the if condition here, and then print it again, once with and once without the stop words, and let's see what we have. So here, this is the original sentence with the stop words in, but a clean text, and it says I've got 18 words. In the second example, it is without stop words, and then the number went down to 11, and then you can see phrases such as and, is, us, and how have been removed, and now this is your text with no stop words. Okay, we're going down towards visualization. We're just like getting our text ready. So what if I want to add something to the stop word list? So what if the word text is actually a stop word in my corpus and I don't want it to be counted? I want it out of my analysis. So Spacey allows you to add a word, a stop words. You can just say stop words.add and it's text. So I do that and then print them again. So now here I print the data again. And if you search that, you'll find the word text has been added in as a stop word. Oops, so I just wanted to show you where it is, and it's here. Okay, so you can see now the stop word text which we added is now highlighted in yellow, and it is part of the stop word list. So here what I do is I just reload the whole thing again to make sure the new stop word list has been included, and then again get rid of stop words from our original sentence. I run that, and then I print them again. This time, no stop words, and then the word text has been included. So if I look at my sentence again, it's the same sentence, no stop words, but this time the word text has been omitted because now it's considered a stop word, and I ended up with 10 instead of 11. So this is just like a way of pre-processing and make sure your text is ready. So now I want to do some visualization. I've got my text tokenized, cleaned, and everything, and I'm ready to do more on it. So what Spacey allows us to do is part speech tagging and dependencies. As we've seen before when I was presenting the slides, I can take the text from each token, get the part speech for each token, and get the dependency for each token, and then I can print them. So if I do that, it's going to just print them in plain text. Today is a noun, and is an auxiliary, march is a proper noun, etc., etc., in a compound or conjunction or other dependencies. And that's where we want to do visualization. So this might be hard to read unless the person knows what he's talking about. And even if they know, it's always better to visualize it. And that's what we want to do. And that's what we're here today, is to do visualization. So in Spacey, there is something called Displacey, and it's basically displays the dependencies and the part speech tags of your document that we created up there. with all the information that we had, such as the part speech tags and the dependencies. Very simple, very straightforward. Like you just import and it's one line to say, display that. You click and then you get the display printed on your screen. It might be very difficult to see it on Jupyter, but I'll show you how to save that to file. But now my full sentence has been visualized here, and I'll show you later where it goes if you want to save it. You can do that in any other styles. So Spacey allows you to add options for like font and background color and all these things. So you can check the Spacey website here for more details. So again, if I run that, I end up with another style. I don't think it's cooler, but it is a different way to do visualization. But the problem now, it's displayed on Jupyter and it might be difficult for you to include in your paper or research. So the best thing is to save things to file. So everything we're going to visualize, I'm going to save it to file to show you how to get these things. All right. So what we can do with Spacey is that we can save it to what we call an SVG. So basically a scalable vector graphics. That means the more you zoom in, the more it's recreated and never gets pixelated. It's always crisp clear. So that's the same one we've seen up there, the very big one. I'm just going to save it to a directory I call plots. And I'm going to call it dependency plot.svg. And that's how you save it. And make sure it's UTF-8, because if you're working with other languages, UTF-8 is important because there are more Unicodes than the English letters. So if I run that, and I go to the directory where the whole thing is, I've got a magnifier to help you see better. So if I zoom in here, and I go to the folder where I have, I don't know if you can see that. I'm just wondering if you can, but if you can't, that's fine. Let me see if I can do that. I think what I can do is share the whole screen so you get everything. Yeah, that's what I do. Okay. So this way you can see it. All right, so if I zoom in, you can see the folder where the plots folder is. So that's the plots directory. If I go in that, I find that I saved my plot into an SVG file. You can open that, and now you've got the whole thing. So the reason it's scalable is the more you zoom, the more it's scaled, and it's never pixelated. It's always crisp clear, as I said. So that's just a way of saving it. And we go back. So that's one visualization saved, and then you can do the same thing with the other. You can also save it. But we move on. So what about named entities? So we visualize the dependencies and the part speech tags. So here I'm telling Spacey to add the NER tags to my text, which is the sentence we had before. So basically I want the entity with the text, like the word university, and then the start and end of the characters. So within my text, where does it start and where does it end? And then finally, the label itself that is given by the named entity recognizer. So if I run that, I end up with this sentence where only the labels related to named entity has been picked up. So today is March 18, 2021, starts from 0 to 24, and it's a date. The same thing for Mahmoud, which is my name, from the 29 to 36 character, and it's a person. And finally, Lancaster University is an organization. And what do you want to do? We want to visualize that. So again, Spacey allows a one-line visualization where I can just visualize my document, which I created up here, and see how does it look like. So if I run this, again, I end up with a visualization of my stuff colored. And the most importantly thing is I can save it. So how can I save it? I can save it to HTML file. So again, you import the path library from Python. The rendering here is to work with Jupyter. So this layout is called Jupyter. And for it to be displayed well, you might have to turn on or off for Jupyter, but I'm going to turn it off because I'm saving it to file. So again, in the same directory called plots, I'm going to call it nerplot.html. So I run that, it's saved. I go back to the directory in the plots. I know the font is small, I'm just going to click on it. So I have a new file called nerplot. And again, it's scalable. You can zoom in, zoom out, and the accuracy is still quite high. So that can be taken, added to your paper, to your work, to your slides, etc. So this is just a basic introduction to Spacey, and it's really important package. It's very easy to use. There's a lot of options that you can do. So go online to Spacey. They have a lot of tutorials that you can follow and run it actually online on their website. So that's it. We've done the first tutorial, and we visualized part speech tags, dependencies, and named entity recognition. Okay. Now we move to the next tutorial. I might be a little bit fast. I'm just trying to cover as much as I can in short time and give you space to ask questions. So hopefully it's still comprehensible in that speed. All right, so the second part of the tutorial is what we call visualization of topic modeling. So this is interesting and important, and a lot of you might have already used LDA. So the latent directlet allocation is a way to like find relationships between words in a certain text, and also find the topics, the text you're talking about. So you might have used LDA, but you wondered, how do I display that? So it might be a little bit complicated to do it with other tools and stuff, but there is a way, and of course it's Python, and Python here helps us to visualize an LDA topic modeling using what we call LDA display or LDA visualize. Okay, so again, I provided as much text as I can, a lot of information. I add text whenever I can. If you see things like capture, so capture is just there to like capture warnings, so it doesn't show on the screen. But be careful, capture will capture your output as well, so it won't show it. So maybe make sure it's not there when you're printing something. Okay, so here we go. I'm going to start with this one. So a lot of importing like stuff like NumPy and Pandas, and I explain why we need those, especially if you're using like multi-dimensional arrays. NumPy is important. We're going to plot using Matplot library and Seaborn, and then finally we're going to use sklearn for count vectorizer. I'm going to explain what that is in a second. So run that, import all the packages. You can see up there, it's still processing. It might take a few seconds for the libraries to be loaded, and it's done. And here, before I start, I need to explain what kind of vectorization is it that we're talking about. All right, so in the beginning, in the slides, I said that you as human can read the text and you can understand it, but then you want to pass it to the machine and ask the machine to do machine learning or some kind of analysis. And we all know machine learning, the underlying of it is math and stats. So no text, everything is a number. And unless you have it as a number, it won't be processed. So that's when the conversion happens. So you need tools like that in order to do, to convert the text into numbers. And the way we do that is we want something to represent the text, right? So if I have the word, I don't know, computer appearing 5 times in my text, so 5 now is a number, right? So that's a frequency. So now I'm representing that text into a number, and now I have something to use with my machine. So that's basically what we're doing. We're converting all your text into numbers. The machine will do the analysis, get the results, then display it to you in a visual way. Okay, so if you remember, I said we've got a lot of CSVs from a conference called CCC for the past 30 years. Just be careful, the delimiter in those CSVs is a colon instead of a comma. I don't know why. I just to show you that you can control the delimiters here. So Pandas will help us to read a CSV file, and I'm going to just print a random 5 rows. So if I run that, it will go read your CSV file and print just a random number of 5 rows. If you run that again, it prints another 5 rows. Just to show you what columns and what kind of data you have, just to give you an understanding. And most importantly, just to make sure the machine can actually read your data. Cool. So we've read the data, we've got all these CSV files loaded, and now I'm interested in some of them. So what do I want to do? So I want to take all the titles of this conference, all the papers that have been submitted, all the talks, I want to take the titles of them, put them all together in one block of text, and then try to detect what topics all these titles are talking about. Okay, the topics could be anything, but the machine will tell you. It could be like security, I don't know, software, browsing, etc., etc. That's what we want to do. That's what LDA will help you to do, and then we'll visualize it. So what is title? So it's just the name of the column here. So in the CSV file, there is a column called title. If you use abstract, it's going to be abstract. Okay. So what I do here is I loop through all the titles in that column. I just put them all together in one list. So run that, done, read all the column, the whole column into there. I can print them for you to have a look and see how they look like. So here it's just saying the title appears once, the title appears once, etc., etc. So it's kind of like, think of it as like a simple dictionary or an array. So now I've got all the titles in the conference in one list. And as I said, it's in both languages, English and German, so you'll find a lot of words. And we continue. So in all the examples, I'm gonna like deal with the titles of the conference, but I've also added the abstract for you to know how to do it. But later on, you can do the topic modeling on the abstracts yourself. I'm just gonna show you how to do it on the titles. Okay, so again, run it on the abstracts, make sure there isn't any empty values in there. Okay. In Python, definitions is like a function in Java, for example. It's just a method that you call. So for now, it does nothing. It's just there. But later on, I'm going to call it with text. Just pass text to it, and it'll give me back the output. So what I'm going to do is I'm going to have a Spacey tokenizer for the English language. Put here just like as an example. And what it's going to do is split the text into tokens, fix some stuff. So people dealing with Twitter, that might be interesting for you, because it says if the token looks like a URL, add the word URL instead of the link itself. Check mentions to hide people names on Twitter. So instead of saying at Mahmoud, for example, you will say, okay, replace that with screen names, so kind of anonymization. And then it converts all the tokens to lowercase. Again, that's your own choice. If you think you need to do that, it's better to do it to have list tokens in your list. You need to run that, but nothing comes out as an output. And it's here loading the model from Spacey, the English model. Takes a few seconds, then it stops. Okay. So the next part is actually Nltk. So Nltk is another library in Python that does NLP and text analysis. So the reason we need Nltk here is to get the morpheme of the word, or what we call the lemma. All right. So if you have something like worked, it's going to show you work, removing the ed. So it's just to help the LDA find more related word as much as it can. Okay. So again, it's just a method. I'm going to call it getLemma, and then from Nltk, I need to download the English and the German stop words. Yes, Nltk has its own stop words as well. And I've created a method to pre-process the text. So what is pre-processing? I'm going to get the tokens, and I'm going to only keep tokens that are more than 3 characters long. And I'm going to remove stop words from English and German stop words list, using the English and German stop words list. And then I'm going to get the lemmas of those tokens. Okay, so this is just pre-processing, and pre-processing is really important in NLP and corpus analysis, because you get a cleaner data noise-free, and that's why you're sure and definite that your data is actually ready to be processed. So again, I'm going to load the Nltk model, done, and move on. So this is just a sentence to show you what happens when I run the pre-processing. So I just put like a random sentence like he, she, studied, they also worked, just to show you what happens when we remove top words, remove words that are less than 3 characters length, and also lemmatized words. So run that on the sentence. We're calling the preprocessed text here. So if I run that, what do I get? I get the words cleaned. So study and studied are now the lemma study. Same thing with work. Gun has become go, and what else? Yeah, swim and swam, go and went, whatever. And then no 2 words, 2 characters words, or 1, and also no stop words like and, they, and all, like also, etc. all have been removed. So I did a cleaning. So the reason you do cleaning, you remove stop words and you remove things, is because you're trying to like reduce the space in the vectorization process. You remove a lot of noise because those won't tell you anything if they repeat a lot. Okay, so the same way I've done it to the sentence, I'm going to do it to the title data. So, so the title data is the data I found in the column called title in the CSV file. So what I'm going to do is tokenize the data and just start counting words. So that's my process of converting text into words based on frequencies. So it just basically says every time you find a word, add the counter with 1. Okay, and they're here. I just like print 11 words just to show you what happens. All right, let's do that. So if I run this, it's just gonna split. Oh, sorry, it's just like splits the text into tokens, sentence by sentence or title by title. So that's what it does. It just splits words into 1 by 1 for each of the sentences or the titles for each talk. So you're not counting it. And you can see each one of them is a sentence on its own with its own tokens. Okay. But I do the same thing for the abstract. So run that. It does it for the abstract. It prints something, but you can see the abstracts are a bit longer than the sentence title. So all that is just one abstract, tokenized, no stop words, no words less than 3 characters, etc., etc. Okay, so now I've got my data cleaned, tokenized, and everything. So now I'm going to start to be ready to do topic modeling. Okay, so I'll try. So what we do is, I know the break is within an hour, so we'll finish this part of the tutorial, then we take a break for 5 minutes. And also I can answer questions in there. Okay, so Jensen. So in order to do a topic modeling, I need to create I need to use Jensen to order, and I just want to move this away. Okay, so I just want to like create a list of, let's say, the words, IDs, and their frequencies. It's just like a way of vectorizing everything and coming up with numbers. So basically a document to bag of words. Okay, so maybe read more about Jensen. You'll find the link there and some information about what Jensen is and how to use it. So basically it takes a dictionary. So our dictionary here is the title text data. So we take the data 1 by 1 and then create a list of word IDs, like the word hello could be 1 and it appears 17 times, etc., etc. So I start to create my own dictionary. So, and I'm going to save them so you can find them there as a pickle and a Jensen file. So these are just to serialize Jensen into a stream of bytes for it to be able to be run by the machine. So the machine can't work with text directly. It needs to convert it into something numbery, and then it can work with it. So if I run that, it just creates them for the titles, again, creates the models for the abstracts, and it says now I'm ready to do the things you want. So what do I want to do after serializing Jensen, and I got the dictionary or like the document to bag of words of the word IDs and the word frequencies? Well, I want to find the topics, okay? So now LDA is going to be used to say, I'm going to find relations between words and find what are the most common topics that your text is talking about, okay? So again, a lot of things to read about, especially about LDA topic modeling, but here's some important things. So number of topics is how many topics you want that text to be represented in. So you can say, I want 5, 10, 20, 50 topics. Think of it as number of clusters. So you want to like divide the text into smaller number of topics, let's say 5, and each of those 5 topics are going to have a number of words. And again, I said 5. Okay, so basically, I'm going to have 5 topics. Each topic is going to be made of the most important 5 words. And then it's up to you to know what each topic is talking about. The machine is just creating them for you. So to explain, if I run that, the machine is saying, okay, your text now is made of 5 topics from 0 to 4, and each topic has 5 words, 1, 2, 3, 4, 5, and each one of them is showing a probability to say how important is that to your topic. So basically, my topics, then I can myself give them labels, but for now they don't. So I can say the first topic talks about data security and some German words. And then the second one talks about like security, surveillance, and data. The third one talks about hacking and moon. I don't know why moon is there, and internet, etc., etc. So here we started to get information about my text in terms of topics. Okay, so I've got my text into 5 topics, and I'm ready. Ready for what? Ready for a lot of things. One of them is visualization. Okay. So now I've got my text into 5 topics. I can do something really cool, is I can get a completely new sentence that my system didn't see, Jensen and Pickle didn't include in their list. Well, maybe included later, but they include this exact sentence. And then I want to see which topic does this new sentence fit in. Okay, and that could be a system or software or tool you can create later, is to see, based on your training data and text, if a new sentence comes in, what is it going to be classified as, if that can be used as a term? Okay, so you do the same thing on it, and then you run that model that you created on this new document to see what happens. Okay, so we have an LDA model that we created. We just get document topics and say which one fits with that one. So if we run it, we get information such that. So this is saying basically you've got 5 topics, and this sentence has those probabilities for each one of them. So a quick look here, I can say that I think topic 3 is the most relevant to this sentence. So what is this sentence talking about? It's talking about, I don't know, privacy, security, services. And what does topic 3 talks about? Well, it talks about like security and, I don't know, the world or other stuff other like that, or something like that. So in our case, this might be the case that this sentence belongs to that topic, but also says it's also relevant to the first topic, which also talks about security and data and etc. So in this way, we just found, like, if I have a new sentence, which cluster does it go into? But so far, all that sounds complicated, and I can't really see what's happening, right? I want to see it visually. I want to know what's going on. So that's when we do visualization, right? So LDA display or LDA Viz is going to help us visualize the model that we created. So what we need is the dictionary, which is the title dictionary with Jensen that we created. We need the corpus. So the corpus is the pickle file that we created from the title corpus. And then we need the LDA model that has been generated, and we saved it. We called it title model.jensen. So all these can be found here. If you go back to the directory, there is models, and in that you'll find all the files that we created. Okay, so run that. It's going to take a few minutes as well for it to collect all this information and try to display it back to you in the LDA visualizer. Yeah, it takes time. I mean, the bigger your data is, the longer it takes, and also it depends on your machine. This machine is supposed to be a good one. So it's going to create it here. but it might be difficult to display. So what I did is I saved it in the plots directory, and I called it titles lda.html. So if I go there and open it, because it's going to be displayed better. So here I'll find titles LDA. So if I open that, I'm going to have like a better view. So what is this telling me? It says you've got 5 topics, right? Yes. So I've got 1, 2, 3, 4, 5 topics, or 4, 5. And then it shows for each topic, if I click on it, it's going to show me the most important words that represent that topic. If I look at lambda up there here, if you see the slider, so when it's 1, we're talking about relevance. When it's back to 0, we're talking about frequency. Okay, so what is relevance? Relevance is a statistical way of LDA finding a relationship between words. And if we say, no, I just want it based on frequencies, just put it back to 0, and these are the most frequent words in that model, and have it 0.6. I think the paper recommends 0.6. So I've got loads of details about LDA and how to understand this diagram in the paper itself. Anyway, you can go from one topic to the other. You can click on a certain, like, I think you can view a certain word and then see how that word appear and which topic, etc., etc. There's a lot of things you can do, but again, what you've done here is you visualize your topic model, and you've got like percentages here to say that the top 30 most relevant terms for topic 4 makes 17.5 out of all the tokens in my data set, something like that. So the more topics, the more circles they're going to have. Some circles are going to overlap. So remember, in our example, we said that the new sentence belongs to like either topic 2 or topic 3 because it's somehow similar to each other's. So that's just a way of interpreting what I've got. So this is for you topic modeling using LDA and Visualise. So it might not be very easy to like understand from the first time. So when you go back here, there is more details. There is a YouTube video to explain to you how to understand this diagram or the visualization itself. There are more details as a paper as well, talking about the whole thing for you to reference and look at. So more details from a paper by Stanford. Everyone talks about it in more details, but how to do it, this is how to do it using Python. So the last thing in this tutorial, it's going to be, I'm just going to look at questions. Yeah, I think it, as I said, it was like the 0.6, but check the formulas down there. I think that will be helpful a bit. Okay, so one more thing to do with LDA. So we've got a topic by topic. So if you find that diagram a bit confusing and it's not helping you to understand each topic on its own, and it's even like more problematic to plot in your paper, so you can do a diagram for each topic on its own. All right, so this is just to call some of the libraries that I need in order to plot. I call all these, and then down here is what I need. So I'm just gonna plot each model. So a figure size, so this is just a size of 15 by 30. How many topics do I have? I've got 5. What do I need to do? I want the term, so the word itself in that topic, and the probability. It could be also the frequency. So I'm just, based on those information, I'm just going to create a column chart or a bar chart in this case. And it loops. So it loops, it means it creates one for each diagram. So loops through it and plot, you can see one by one. So if I run that, I'm going to end up with 5 charts or 5 bar charts for each topic. So topic 1, topic 2, topic 3, etc. And each one with the most important words and the probabilities for their occurrence in that topic. And that for you, a visualization of each topic you have. The more you have, the more charts you're going to end up with. If you're not happy with the color, you can choose others. So I think if you type like greens and then run it, you're going to end up with green diagrams, reds and blues. I think the more you read online, the more colors you'll find. So, and again, I'm going to show you how to save it. So I think I saved it at some point. If I don't, yeah, if I haven't saved it, you can just use the saving from the previous one. So just go here and look for how to save something as an HTML or save from plot. But anyway, later in the other examples for the other tutorials, I will also show you how to save those figures into your machine. Okay, so this is the second part of the tutorial. So we finished 1 and 2, and now we take a 5-minute break, and then we continue with our remaining topics. It might be like fast-paced again, but as you said, we're trying to like cover as much as we can. So here you go, 5 minutes break if you want to go grab something to drink. So Gloriana had a time, so 2:15 is the time for us to be back here. And for those who have questions, just throw them in the chat, and I'll try to answer as much as I can. Okay, so there's a question about named entity recognition. So you can actually go and retrain them based on your certain data. But what it does, it's not like it has those words somewhere and just like locks them up. It works on based on like training. So that's how it used to work, whether it says Lancaster University or Essex University, etc., etc. So do you think it is worth linguists investing time into trying to learn to code, or would it be better to work with IT specialists? Okay, so what I would recommend is for some basic stuff like tokenization using Spacey and the stuff that we covered so far, you can hopefully do that on your own if you know like how to do the setup itself. For more complicated stuff, let's say into like more machine learning and deep learning, um, it's up to you. So I've met a lot of really good programmers who are linguists, and they've done amazing job using Python and other programming languages. So I don't think it has to do with linguists. It's just to have to do with how much time you have to spare to learn Python. Okay, so this is a good question. So the question there says, how do I, thank you, by the way, how do I go about creating a language package for middle and early modern English, taking into account a considerable number of spelling or like variant spelling? So on purpose here, so when I created the language model here, I only focused on English, despite my corpus having a lot of German words. And when you saw in the output, it still picked up the English words because they are tokens, right? So LDA is more into like, doesn't really care about the language itself. So LDA more about like probabilities between words. It's just based on how many times they appear frequently or next to each other's. So when that happens, LDA comes up with that statistical relationship between them to say they are related. So even if it was, let's say, a different spelling variation even in English, it will still be picked up. But when we talk about like language analysis, if you want to do like a part speech tag or let's say named entity and things like this, most of the time those are, because they're very specific, they have to be trained specifically for that data. But so far, even with just using LDA, I don't think you've got a problem with that. So Paul added the link there about BARD, which talks also about like the variation in spelling. So Paul and Alistair before has done a lot of work with historical data, different spellings. So they are the best people to ask as well. Thanks, Paul. Anytime, thanks. 1 minute of questions before we move on. Cool. Okay, I think we are good to go and continue with the tutorials. So yeah, we've got a few tutorials to finish in a very short time, but I'll do my best. Some of them are very straightforward and stuff that you've used before, and some are not. All right, so I'm gonna move on. Oh yes, yeah. So for the question that says, can it be used with other languages than English and German? Yes. So in the links, when I talk about Spacey and also in Nltk, you will find language models and packages for many languages. Honestly, you'll be surprised and amazed how many languages covered. So go to Spacey and have a look at what languages they cover. And I show you how to import the model. So just like replace that with the language you want. Instead of EN and DE for English and German, you can do Arabic, for example, with AR. I don't know what other languages are there, but I'm sure it's plenty to cover. We've worked with many languages here. Okay, so here we go, tutorial number 3. So in this one, I'm going to talk about a familiar topic. I'll come back to questions when I finish. So I'm going to talk about a familiar topic that is word clouds. Okay, so we all know word cloud. We extensively use them, and they're very much used in the research. And there's a lot of tools online to do them. But the type of word clouds I'm going to show you today is the one that you can control. Like you can control what type of words you want to see and what kind of visualization, especially with backgrounds and images, you want to see, but it will still be as simple as you think it is. Okay, so this is just like preparing the setup for stop words. You import some stuff from Python, especially like matplot and Nltk and word cloud itself with stop words. And here are some information that you need to have for your word cloud. Okay, like information size and the limit on the number of words and what title to give it and if you are the author, etc., etc. So you can put these things here, font color, background color, and then we can see later on how we can control that. And so here's an example for those who are asking about other languages. So Nltk, as I said, is another library in Python that deals with NLP. So you can get the stop words, and then you can say, I want the stop words for English, I want the stop words for German, and then go online and search what other stop words list that is covered in Nltk for other languages. So what I do here is I combine both stop words in one because my text has a combination of German and English text. So I use union because it's 2 sets. So I combine them together and we get what we call a bot stop words. Okay, run that. Models will be loaded, take a few seconds, and then we're done. Here, Nltk just confirming that you've already downloaded this data. You don't need to download it again. But other than that, we're fine. Okay, again, we're going to work with CSVs. This time I'm looking at a 2019 conference from the same conference. The limiter is still a column, and I'm going to print random number of sentences, rows, sorry. Run that, it reads the CSV, prints a random number of 2019 talks, and we move on. So again, I'm going to take the titles or the abstracts, it doesn't matter which one. So here I'm taking the abstracts, which is the column here, and get all the text from the abstracts in order to create a word cloud. So I run that. This is just simple dictionary of a sentence, and then I count one every time, and it skips when there isn't an abstract. So this to avoid getting an error. So run that. I've got the abstract dictionary as we've seen before. And then this is just a method to convert everything to gray. You can ignore that if you like, but just for the type of word cloud I'm using, this is just a style. And then we go. So here I'm going to do the first word cloud. So I'm going to just take the text from the abstract and then plot it on a word cloud. Okay. I'm going to use something called mask. So masking word clouds is when you use an image and you make the word cloud to like follow the shape of that image. So if it's a car, it looks like a car. Or if it's like a building, it will look like a building or something like this. So in the image folder, I've got some few images that you can play with, but you can add your own as well and use them as a mask. Okay, so we don't have any access, so that's why it's off. And here we go. I'm just joining all the words in the abstract together based on white space. So I'll have like a variable called text, have everything from the abstract's words. Okay, I do some cleaning. Okay, I remove anything that is not a letter, anything that is, I don't know, some punctuations. I remove excess spaces, and I end up with a clean version of text. So that's just the text ready. It's called abstract text, cleaned, and I'm just gonna throw it at the word cloud. So here is just the options for the word cloud, and then we generate it. So what are the options? The maximum number of words. We've seen before up there in the first cell that this was 10,000. Do we have stop words? Yes, I've got a combined stop words of German and English. Are you using a mask? Yes, I'm using a mask for an image called 1.jpg. You're going to see that image. What about background color? In the beginning, in the options, we defined a background color. It's the same thing for font. And then I'm just going to generate it. Okay. So this information related to the plot, okay, width and height, and other information that you want to see. And then I show it. So let's run that. If I run it, the process here will say, I'm looking at those words from that list. I'm just going to create a word cloud. So this is my word cloud, but before that, this is the image. So an image of like a hacking, because this is like hacking talks. And because it's a mask, it's going to like plot it on that mask. So these are the most frequent words in my word cloud, if that makes sense. So in my text of abstract, we're talking about like there are talks and systems, new ways and securities and hardware and devices and attack and etc. So this is like a word like a word cloud, okay? But here we didn't control anything. All I've done is clean the text, remove stop words, then plot. But what if I want to do more? I want to like focus on specific type of words. Okay, so let's just have a look at another example of masking. So you can mask with the color of the image. And then I'll look at what other words we can look at. So again, more options, but this time I'm going to ignore the background color, which is white. And then the image color generator is a package that I'm going to use in order to imitate the colors in that image and reflect that on the font of the text. Okay, so it's just like a way of managing a text color, sorry. So again, if you run that, you're going to end up with, still processing, you're going to end up with the mask image colors being converted into the font. So this is the image taken from the conference. And then you can see the font here is actually matching the color of that image. And it's just because it's colorful, we ended up with the colorful shades of orange in this image. Okay, again, the most frequent words appear larger, and that's why it's just showing importance here. The smaller it is, the more insignificant it is, etc., etc. Okay, so what I'm going to do next is I'm just going to look at nouns. All right, so in the previous example, it just went with the most frequent words, regardless of the word itself. But here, I'm just going to tell Spacey, go and get me all the nouns from the text and then plot it in a word cloud. Okay, I don't want to see anything else other than nouns. All right, so from Spacey, I load the English model, I run it over the abstracts, and I say, for each token, go and get me all the tokens that are more than 4 characters long, and most importantly, where the part speech tag for that token is a noun. Okay, this is a long line, but it's just saying that I only need tokens that are greater than 4 characters long, that are not punctuation, and that are nouns. Okay, you can do the same thing, just convert it to verb, and you get the verbs only, etc. Okay, so I'm just going to count the frequencies of the nouns. So you got a counter that will count the nouns in that text that I have, and I get the most frequent, like the most 500 frequent words that are considered nouns, and just print a sample for you to see how they look like. So if I run this, Spacey is going to start loading the English model, part speech tag the text, and only pick up nouns and then display them for me. It's going to display like a few samples for you. So this is saying that the noun called security appears 33 times, software appears 20 times, same with hardware, attack, and system to the end. Okay, this is just a sample, not all the words. Okay, so again, as we've done with the abstract text, we're going to conflate all the text together into one variable that we called all the text from the nouns. So we run that, and we're ready. Now again, we just call the same word cloud that we had before, but this time my word cloud is going to just show the nouns. So if I run that, when it's done loading, it's going to show a word cloud with just nouns in it extracted from that text. So here, most of the words you see here are just supposed to be nouns extracted from the text. There might be some errors here and there, but most of the time it tries to get it correctly. Okay, so this is just like basic word clouds and what we can do with it. The only difference here is that we can define what we want with word clouds. We want to see nouns, we want to see verbs. We can have a limit on the number of words, a limit on the size of the word, etc., and then plot it in a word cloud. Okay, so next I'm going to go into a simple machine learning tutorial using SVM, naive Bayes, and logistic regression. So for many, you'll find a lot of examples online on how to run a machine learning, but in this one, I try to make it as simple as I can. You can read your own data from CSV files and then run a machine learning. But because our data is a different data, so I have data from 1980 to 2019. So what I want to do is create a machine learning classifier that will take a text title of a talk and then tell me which year it belongs to. But because we have so many years, we end up with a lot of classes. So 30 years is 30 classes. For machine learning, that's a high number of classes. We might have a low accuracy. So another way to fix this is I grouped a year span all together in one kind of category. So all the 80s together from, like, let's say 1990, from 1980 to 1989, all together I call it 80s. Do the same thing for the 90s, and anything between 2000 to 2010, I call it 2000. And from 2000 and over, I call it 2010, for example, just like to reduce the number of classes. Okay, so again, there's a lot of libraries that you might now be familiar with that we call again. Just get ready. And now I'm just going to combine my CSVs. So every year has its own CSV. So what I'm doing here is loop through all the CSVs and put them together in a combined CSV file. Okay, so if I run that, it's just saying that The 1984 talks have 11 talks, like 11 titles, same thing for 85, etc. But we have a long span of years that we want to use in our training. So we have 160 titles just in 2019. Okay, let me just double check one thing and then I'll go back. Where is it? Sorry. Yeah, okay. So now we have all the years combined into one CSV file. Then we can start training a model. So what I'm going to do here is, let's go, right? Yeah. So if what I'm going to do here is, again, get the CSV files together and then have what we call a year span. So if I run that, it's just going to open the combined CSV file and show me now all the years are together. So you can see in the same file, you have talks from 2004, 17, 2003, etc. So they're all in one place now for me to work with. Just to show you how to combine files or CSV files using Python. Okay, and then this is where I mentioned that I'm creating a span. So basically anything in the 90s will be called 1990. Anything in the 80s is called 1980. So instead of 30 classes, I'm ending up with 4. So that will change the way we do classification. So run that, does nothing other than like compressing everything into 4 classes. And now we have a combined span CSV. Instead of all the years together, we're going to have a span. So if I run that, it will show me that now you've got 2000s, 10,000, like 2010s, and then the 90s and 80s, etc. All together. So if I run it again, you're going to get other examples from other years. Okay, so there are more conferences in the 2000s and the 2010s than in the 90s and 80s. Okay, so here's our code to do classification. So I'm just going to first take the classes of the years and then pass it to the machine learning to learn those as labels. So what does that mean? So every talk that I have has a year attached to it. So that year can be called a label or a class. So it's the same thing as if you have a movie review and then it'll say positive or negative. So that's the label. In our case, the label is the year. So I'm going to take the years and use them as labels. And then I'm going to train an SVM, naive Bayes, and logistic regression classifiers in order to try and learn the difference in year spans. And then it tells me the accuracy it got. Okay, so you'll find a lot of details here about how to initiate that, loads of importing, but then the important stuff you need to learn is the training and testing splitting. So here we do a train and test split for the abstract and years. And oops. So this is just saying, I want the test to be 30%, and then the 70% left is for training. So this is just me randomly splitting my data into 30-70 for the machine to learn from. Okay, and then as you remember, we want to convert our text into numbers. So what I've done here is I've just done an n-gram of unigrams. So 1-to-1 means one word. So every time I'm doing one word, you can change that, as you can see here in the comments, to like unigram, bigrams, and trigrams, which means either one word or like 2 words or 3 words together, and then take those and count the frequencies for them. So if you're familiar with n-grams, that will make sense to you. If not, it's just a basic way of counting words, but instead of counting one word, you count 2 words together, 3 words, etc. Okay, so here I'm asking the machine to start training. So you transform the vectors you've done for the training and testing data, and then run the models. So we have SVM with its own options. So this is a linear one. We've got naive Bayes, a multinomial one, and then logistic regression. And so what we do is we train, then we test the accuracy. So basically the machine trains itself on the 70% of data that I split randomly. Then it tests itself on the 30% of the data that we chose randomly. And then it prints its confidence. So the machine will say, based on the training and the testing I've done, I think I'm good 80%, 90%, 60% to detect this data correctly or false. So we do that, we print the results, then we visualize it. So the way we visualize it is here we're just like choosing the color, and what we show on the label. So on the Y label is the actual prediction, the actual like class, and then the X label, like the X-axis, we will see the prediction. So for example, if the Y was positive and the X was negative, so the Y is what is originally was, and then the X is what you predicted. Okay, so I'm going to save it. So I'm going to save the plot into a PDF file for each of the machine learning models, SVM, naive Bayes, and logistic regression. So if I run that, we'll start doing some analysis here, and they'll start plotting the output. This is a small data, so it won't take long. So what is this basically saying? It says, using SVM, I got a 99% accuracy training myself on the 70% of data. And then when I tested myself on the data that I've never seen before, I got an accuracy of 71%. So that's SVM, and it's known to give higher accuracy than naive Bayes, at least in our case. So naive Bayes says, I've got 73% while training, and then 63% while testing. And then the same thing with logistic regression. So the difference usually is between 10%. Longer than that, you might have like overfitting. So you need to check. But this is what the machine is telling us. It says, trained myself, tested myself. These are the accuracies. So how do we visualize that? We visualize it in what we call a confusion matrix. So if you remember, in the confusion matrix, the y-axis was the actual classes, and then the x-axis is the prediction. So it says, if we just take one randomly, so it says the machine has managed to get 21 titles correctly classified to the 1990s, and wrongly classified, let's say, like the 12 titles into 1990s when they were already 2000s, for example. So this is basically saying it was positive, but I predicted negative, etc., etc. So you can see the highest accuracy is for the machine to detect titles from the 2000s, so it does better, and then it does worse when it's around 90s and early 2000s. So this is just like to plot and see how your machine did. Okay, so the first plot, second plot, and third plot. So those are SVM, naive Bayes, and logistic regression. And if I go to the plot directory, I'll find them here. So you've got combined logistic regression in a PDF format. And again, you can zoom in and zoom out and save it to your talk or paper. Okay, so this is simply how to do machine learning. Might be a little bit rushed, but just to give you an introduction and flavor of how do you do the splitting, and then how do you do train and test, and then most importantly, how you plot your data in the end. Okay. All right, so after that, we've got a tutorial on simple stuff. So this is basically about word usage. Because we've got data from the 80s to the 2000s, we wanted to see whether a word usage has changed. Okay, is it used more? Is it used less? So the best way to do that is to visualize it in terms of charts, and then plot that and have a look, see what a certain word happens to when it goes through years. Okay, so I'm going to do that to the whole combined CSV file. So that's every talk from every year from the past 30 years. So I'm just going to run that and print a sample of 3 rows. Here it shows like 3 random rows. You can see from 2018, 1998, 2015, so everything together. And as we've done before, I'm just going to put or create a dictionary of all the titles together. Just give me all the titles. And now we have the title dictionary ready with every single title from all the years. I'm going to do some cleaning. I'm going to remove anything that is not within the English alphabets from A to Z or capital A to Z. I'm going to remove like some kind of special characters or excess spacing. So in regex, space plus means one or more pluses, conflate them back into one space, as we see here. Some renaming I've done here because these are in German style words, so I've converted them back to English just for display. So do the cleaning, move next. If you remember, we've done something like that before. Is from Nltk, we get the English and German stop words. So we check stop words and remove them. So that's the first method. We check the length of the token. Is it above or less than 4 characters? You can change that the way you want. So these are just methods to call. And here, I'm going to find some verbs and see how they change across the years. Okay. So what I'm going to do is I'm going to go and load Spacey English model. Okay, put a maximum length here for like 200. You can make it smaller or larger, but it depends on your system. I'm gonna like have my title text, the whole text ready for NLP analysis. So what I'm gonna do is loop through each token in the title text, check it's not an English or German stop words, convert it to lowercase, remove punctuations, and make sure I only get verbs. Okay, so what I've done here is gone through all the text in the titles and only extracted verbs for me to do my analysis. So if I do that and print the most common 10 verbs, it's going to do that for me. So it's going to go through the text, tokenize it, take word by word, remove words that are less than 4 characters length, only extract verbs, and then display the 10 most important verbs for me, and that's they are. Okay, so it says using build-based secretizing, breaking. So here, because I didn't deal with capitalization, so I get 2 different using. So that's a good way to learn why you need to use small letters. Okay, learned, hacking, attacking, etc. So all these are now my verbs, and I want to plot them and see how they change across the years. Okay, so process here is just to get the verbs. We got them with their frequencies. The second process is to get the year from the CSV file. So this is just basically saying go to the CSV file. There is a column called year. From year, get me the unique years without repetition. So basically 1981, 82, 83 to 2019. So run that. I get a list of all the years. And now I'm going to count frequency by year. So for each verb that I have, I will take that verb and then count how many times it appeared in every year because I've got the data in the CSV file. So basically all this does is counting, but it does the counting by year. So just a method, I'm gonna run it, nothing happens. And again, here it's gonna plot by year because if I get the frequency for each word by year, I can plot it on a chart. So the way to do that, so I'm gonna create a method. The method takes the word that we are interested in, let's say usage or using, the years list from 1980 to 2019, and the frequency of that word. Okay, it's going to be like a list of words, a list of frequencies, and a list of years. Some options, and things to display on the x-axis is going to say years, y-axis is going to say frequency. I'm going to decide on the size, and I'm going to create like a vertical like text because the years are long, so I'm just going to have them like vertically shaped. And then I'm going to plot them, and I'm going to save them. So each figure is being saved to the plot directory for you to use later. So this is just a method. We didn't run it yet. And here's the important stuff. So it says, loop through each word and its frequency in the most common verbs, and then go and plot them. So if I run that, it's going to take each verb and then plot it for me. So you can see the x-axis is vertically aligned. So this says that the word usage was not used in the 80s and start to be used in 2000, etc. And you will realize that this is common for most of the verbs. And the reason is the conference started to be in German. So most of the words were German. And then later in the 2000s, they started to include English. And that's when you see English words like occurring, okay? Remember, I only included English words in this analysis for the purpose to show you that the usage differs. And now it's telling us something, right? Maybe not the frequency we wanted. It's telling me that some words started to appear after 2016, etc., etc. And it will help you to understand what topics, for example, people started to focus on, okay? So if you go to the directory, I think I saved them somewhere else. Let me see where I saved them. Yeah, I saved them in plots, so I just need to refresh, I think. So they are here, each one of those. So the word securitizing, if I open it, it's going to show me the chart. Maybe that word doesn't appear that much, and the word using, etc. So each one of them will be saved in a PDF file. So this works for us because we've got a span of data. Okay, we've got many years that we can go through and check the frequency of a word and then plot it to see how it looks like on a chart. Okay, this is very simple, just to show frequencies and how we plot them. And then finally, before I take questions, we're going to talk about word embeddings. So I've added this in the end because I thought word embeddings are cool and maybe someone wants to do that. So this shows you how to create word embeddings and also how to plot word embeddings, which is something that might be interesting for many of you. Okay, so some information here about how we plot word embeddings, but you might need and go read online about what word embeddings are and what they mean and how they find the relationship between words and how we end up with a long vector for each word and what does that mean. Okay, so again, we start to import packages. So the same thing as before, like Nltk, NumPy, and regular expressions. So import all that. And again, we're going to remove stop words. So we're importing stop words from Nltk. We're going to do some cleaning for the text like we've done before, remove special characters, extra spaces, rename some words, and also make sure that no stop words are included and no words below 3 characters. So we're just trying to find a way to like reduce the number of words in our vector space. Okay, so didn't run this yet. We're just gonna keep it there, and we're gonna have a method to build our corpus. So this is just gonna go get the sentences and append words to the word list because you have a dictionary of all the words that appear in your corpus. And then I build a corpus of all the titles in the CSV file. So didn't run this yet, and I'm going to start here. So what I'm going to say is just show you the first 2 sentences in my corpus when I run it. So if I run that, it's just going to say, here's your first 2 titles split into like first as they are and then split into tokens, clean, with no stop words, with no punctuations, etc., etc. So you can see because we have German words removed, so some German stop words being taken off, and that's why we end up with a cleaner data. And in this time, we've lowercase. It's recommended in this process at least to like do a lowercase for your data. So this is just so far preparation of the data. So now we're going to create a Jensen model. And as I said, you need to like read what Jensen model is. But basically, we're doing what we call a word to vec. So basically, it's a vector of all the words that are related to a single word. I'm going to show you what that means. So in vector space, you can define the size. So that's like the space that you have, the window to search for, and the minimum count. You can say, I only want words that appear 5 times and more, 10 times and more, or maybe just 1 time. And then the processes. If you heard of skipgram, so skipgram here is off, which means it only does continuous bag of words. But if it's 1, it's going to do a skipgram instead of taking word after word when finding relevance. So I do that. I do a word to vec, and I save it. I call it word to vec.model. So run that, and it's saved. So it depends on how big your corpus. Usually it works with large corpora in order to create a lot of data related to each other, then give you vectors. So what does vectors mean? So I know that the word computer exists in my corpus, so I'm going to test to see how does the vector for this word look like. So if I run it, it's going to show me something like this, which might not be very easy to everyone to understand. But this is just showing in the dimension all the vectors related to this word. So this is now going to make you think. So what's going to happen is when you plot on a chart, you've got an X and Y, and you know the point where you want to plot something. So if you know that the word car comes in the X-axis of 1 and in the Y-axis of 10, so you know it's going to be placed, right? But what about a vector like this? How do you plot that on your chart? So that's the challenge for plotting word embeddings. And this is what I'm going to do today, is use something like TSNE and CPA or PCA, sorry, in order to like reduce that space into a plottable space. Okay, so that's, I think, the easiest way for me to like to describe this is I'm going to convert all that number of vectors into small vectors that I can actually plot on the screen. So basically find a way to represent that into X and Y. I hope that makes sense. It's just like, because otherwise this is a very strict dimension of 300 or 100. That's going to not be easy to like visualize on just a 2D screen. Okay, so what if we don't have the word? As I said, it depends on how big your corpus is, but in my corpus, it's very small. It's about a conference that I've been running for 30 years, so how big the data could be. 10 million, 20 million, but you need more. So if I look for a word like Lancaster and try to get the vectors for it, it's going to give me an error. It says, well, I wrote that, but it says the word Lancaster is not in vocabulary, or what we refer to it is OOV, which is out of vocabulary, which basically says when the word embeddings created a dictionary of all the words in your data, the word Lancaster was never found. So that's why it can't have a vector for it. So you need to find a way to deal with out of vocabulary words, and otherwise you're going to get an error. And also have more data in order to represent everything you want in order to find relevant words to the one you want to test. So what does that mean? Okay, let's have a look. So here is just the TSNE plot. So TSNE, as I said, is a way to say I'm a scatter plot that I want to do a distributed stochastic, like lowering the dimension that you have from 100 back to a plottable range that I can plot on an X and Y chart. So this is done using PCA, but there'll be loads of talk about it online to exactly understand what's happening if you're interested in how this works. So more details to find online. But what we care about here is we are trying to reduce the dimension of each vector in a way where we can plot it on the screen with an X and Y. Okay, so what I'm going to do is I'm going to plot it and I'm going to save it as a PDF file in the plots directory just to show you how to save it, and then run a few examples. So this is just a method, we're just going to call it. And here I'm creating my own word to vec of size 100 with the minimum count for each word to be 10. And it's a continuous bag of words because the skip ground is off. I'm going to save that as word2vec model number 10. Run that. It's going to happen quickly because it's not much data. I just went with words that occur more than 10 times, and I'm going to try and plot it. So if I try to plot that model, it's going to take a few minutes because it's a lot of words, and the larger it is, the more it takes, but this one should be as quick as possible. So what's happening here is the word vector is telling you, these are all the words that I think are in your data, and this is relevance to how close they are from each other. So if I go to the plot directory, I'm going to find it there as a PDF file. And if I open that, it's going to look slightly better because I can zoom in and read some of the words. So here it's saying all the techniques are actually related to each other. Okay, it's going to say something like secret and analysis are related, and some German words related to each other. Breaking frame, okay, network and software, hacking. So future and way. So some of them will make sense to you because all the machine did is it trained a word vector on your data, finding relevance between words and created this word vector. And what we've done here is we reduced that massive dimension into a way where we can plot it on the screen in a reasonable dimension. That's what we call it. Okay, so otherwise this is going to be really complicated to plot. So this is not all the words. This is just the words that appear 10 times and more. If I make it one, it's going to take a long time to be plotted, and it's going to be like very, very dense, but just for you to look at if you're interested. Okay, more. So what I'm going to do now is do the same plotting, but for each word. So I'm going to find a word, and then, so I'm just going to scroll down a little bit. Yeah, so I'm going to find a word and then find all the words related to it based on the word vector that I created, or the word embeddings that we created, and then plot that word with all those relevant words to it. Okay, so we're going to use the same TSNE scatter plot, but this time we're going to have the word embedding model, the word that I'm interested in, and then the list of names, what we call is the list of words that are related to it. Okay, let's see what that means and how it works. Okay, so if I take a word like security, which I know it does exist in my corpus, and I tell the word embeddings, find me the most similar words to this. So if I run that, it's going to say, I think the words, I can't read most of them, but I think the word mapping and steps and assured and ecosystem are all related to the word security. Remember our previous chart? So that's where it gets the information from, but based on the actual vectors. So here I just got the most similar vectors or most similar words to my word security, and then I want to plot them. So as I said, to the plotting, I'm going to send security, the list of words, and the word2vec model that we have. So if I run that, it's going to plot those words and then show their distance, if that makes sense, from the word security. So I've got the word security here, and I know the word mapping is very close to it. The word compiler with a double C, I don't know why, is further away from it, etc., etc. So this is how to plot a very complicated kind of like visual space into a plottable space, if we can call it, using charts and using TSNE and PCA in Python. And again, this is saved to your machine. So if you go here, you'll find the word security and the plots. And again, this is sharper and better quality. You can control the way the charts look like, what you want to see on the X and Y axis, etc., etc. It's up to you. The most important thing is to show you how you can actually plot word embeddings in Python. Okay, so this takes us to the end of the tutorial. So what we've seen so far is 6 ways of analyzing textual data and presenting them to the end of the tutorial of today. So I'm gonna, after the talk, just release the GitHub link and make it available for everyone. So yes, so the link added there is correct. So that's my GitHub, but I'll try to make it as soon as possible, freely available for everyone to try it. Okay, so I'm going to stop here